Hey guys, so right now you should have your notes out from Monday and you should have the notes for today, and then you also need to have a calculator. So if we don't have those things at this point, we can pause the video to give everybody a chance to get exactly what you need. All right, so on the notes from Monday, we stopped at section 4. We graphed the 3 graphs and we started filling in and answering the questions down at the bottom. Okay, so we said that from graph 1 to graph 2, the anchor point 0, 1 became the point 0, 2, and from graph 1 to graph 3, 0, 1 became 0, 1/2. So I think we quickly said that in graph 2, which is up here, right, sorry guys, right here. So from here to here, the distance. So how far is the anchor point from the asymptote in graph 2? Well, that is 2 units. And then the same for the third one. If we look, the point from the asymptote was 1/2 a unit. Does the change match any part of the equations up here? So here I was 2 units and here I was 1/2. Do you notice that it matches the number in the front? Okay, so the change matches the dilation that's found in the front of the equation. So the change matches the dilation that's found at the front. Okay, hopefully you guys have that written down. So let's generalize. So any exponential function of the form y equals a times b to the x will have a vertical stretch if a is greater than 0. Okay, so if the number in front's bigger or greater than 1, I'm sorry, it's greater than 1. If the number in the front's bigger than 1, then that's a vertical stretch. If the number is between 0 and 1, it's a shrink. Okay, it's not less than 0, it's between 0 and 1. Numbers that are less than 0 are negative numbers, and we know that a negative in front of an equation implies an x-axis reflection. Okay, so we're going to use what we've got up here to generalize or to answer some of these questions. Okay, so describe the dilation that occurred in the exponential functions below. So remember, we're looking at the number in the front. Okay, so I've got a 2. 2 is bigger than 1, so is that a stretch or a shrink? That's a stretch. Number 2, 0.5 times 3 to the x. I'm looking at 0.5. Well, that is between 0 and 1, so that would be a shrink. Okay, number 3, 4 times 10 to the x power. We're looking at the 4 in the front. 4 is greater than 1, so that is a stretch. Okay, number 4, negative 3 times 3 to the x plus 5. All right, you ignore the negative. That negative sign implies a reflection. Okay, we're only looking at the 3. Okay, so the 3 is bigger than 1, so that would be a stretch. Okay, so you guys had a homework sheet that you were supposed to do. So what I want you guys to do, and you will work on this after we finish this video, is I want you guys to finish that homework sheet from Monday night. I told you you could do some of the sections, but you couldn't do them all. And even if you did them all, I do want you to go back and double check, especially if you tried to do the dilation section, make sure that you did it correctly. So that is your first assignment for after we finish notes. So the first assignment after we finish notes is to work on that homework sheet. Okay, so now we are going to the notes for today. So you've got a 4-question warm-up at the top. We'll just work through it together. Number 1 says to describe the transformation from f of x equals 2 to the x power to g of x equals 2 to the x power minus 7. So I want to know what happened. Well, if you notice, the difference is just this minus 7 back there. Well, if there's a number in the back, what does that imply? That's your vertical shift. So this one is shifting down 7 units. Number 2, describe the transformation from f of x to g of x. So I want to look from f to g. What's the difference that I notice over here? You guys see that negative? That negative is in the front. So do you remember what that means? That is an x-axis reflection. Okay, so number 3 and number 4, you're going to find the y-intercept algebraically. Algebraically means you got to do some math. Well, you guys remember how to find the y-intercept? Nathaniel, I bet you're back there about to die wanting to tell me how to do that, aren't you? So we plug in a 0, right? Plug in a 0 for x. So f of 0 equals 3 times 4 to the 0 power. All right, so in your calculator, you guys are going to plug this in, and it's going to look like this. So 3 parenthesis 4, close it, caret 0. Okay, so plug that in right now. You need to make sure that you can do that. So what did you guys get when you plugged that in? You should have gotten a 3. All right, so it's asking for the y-intercept, and remember that's an ordered pair, so it would be 0, 3. Okay, number 4, find the y-intercept. Okay, so same thing, we plug in a 0 for x, so f of 0 equals 3 times 4 to the 0 power plus 4. So in the calculator, what's this going to look like? This is a little different. You're going to do 3 parentheses 4 caret 0 plus 4. Okay, so take a minute and plug it in. Make sure you can do that. Okay, everybody's plugging in. Corey, Zachary, y'all make sure y'all are doing this. Your fingers should be moving on your calculators because you're plugging these things in. Did you get a 7? You should have. And it's an ordered pair, 0, 7. Okay, so we are today going to be actually graphing the things that we looked at yesterday, okay? But we're not going to do the t-tables, and it's not going to be so complicated. We're going to use our transformation steps to graph exponential functions. All right, so how are we going to do this? So step 1 is to plot the horizontal asymptote, okay? So remember we said that the horizontal asymptote is equal to the vertical shift. So whatever the vertical shift was at the back end of the equation, we take that number and we set it equal to y, and that's your horizontal asymptote. Remember, an asymptote is a line that you're approaching. The curve approaches it, but it never actually crosses it, and we graph it with a dotted line. Step 2, you're going to plot the initial anchor point. Initial means starting, so that's your starting anchor point. That anchor point is going to be the ordered pair 0, a. Well, remember, a is that number in the front. Okay, so step 2 is to plot the initial anchor point. Step 3, we're going to shift the anchor point horizontally. Well, that means left or right. Step 4, you're going to reflect the anchor point. All right, that could be an x-axis reflection, that could be a y-axis reflection, whatever it is, it could be both. You're then going to reflect that anchor point. Step 5, you're going to shift the anchor point vertically. I'm sorry, y'all, I thought I hit pause, but I didn't. So step 5, you're going to shift the anchor point vertically. So this is going to be your final anchor point, and that's the one that you're going to use when you are graphing the function. Step 6, you're going to algebraically, which means do some math, find the y-intercept. So just like we did in the warm-up, you're just going to plug in a 0 for x and evaluate. Step 7, you're going to sketch the graph. Okay? And sketch is what you're filling in your blank there. So all graphs have to contain the final anchor point, the horizontal asymptote, and the y-intercept. So those are the things that I'm going to be looking for. Okay, so we've got some that we're going to try to do together. All right, so number one, make sure everybody's with me as we're doing this. Okay, so all your phones are put away. They're not in your lap. You're all paying attention. Okay, so number one says f of x equals 3 to the x plus 2. All right, so I've got a box over here, and I'm going to fill some of these things in. Okay, so I want to know, is this growth or is this decay? Well, my base determines that. So I'm going to look here. My base is 3, okay? We know that that means that this is growth. So I'm going to circle growth. And what I'm going to do over here to the side, I know that a growth function starts small on the left and it curves up to the right. I'm just going to sketch a general shape of what that looks like. Okay, and I'm doing that because when I get ready to go and draw my final graph, it's going to help me remember the shape that it needs to have. Okay, so now I need to figure out the initial anchor point. Remember, the initial anchor point is 0, comma a. Okay, so we need to be careful. 3 is your base. So if 3 is your base, what's the number that's understood to be in the front right there? You guys agree that there's like a 1? Not like 1 times 3 to the x. 3 is not your a because the exponent's attached to it. So it's the base. So a is 1. So your initial anchor point is 0, comma 1. Okay, so now I'm going to look for a horizontal shift. Well, if you remember, a horizontal shift occurs up there with the x value in the exponent. There's nothing there, so there's no horizontal shift here. All right, then I look for a reflection. Is there a reflection in the front, or is there a reflection here in front of the x? No. So then I want to know, is there a vertical shift? Remember, your vertical shift is what's back in the back. I see a 2, and it's positive. We obey the sign. So up 2. All right, do you guys remember that vertical shift also tells you something else? Doesn't that tell me my asymptote? Okay, so I'm going to go ahead and I'm going to write, I know the asymptote is y equals 2, so I'm going to go ahead and fill in that blank. Okay, so I'm ready to graph this. So I'm going to follow my steps. Step 1 is to plot the horizontal asymptote. All right, so I know it's y equals 2, so I'm going to go to the y value of 2, which is right here, and it's a horizontal line. So I know I'm going to have a dotted line at y equals 2. Okay, so a dotted line at y equals 2. So then the next thing is to plot the initial anchor point. Well, I wrote the initial anchor point over here in my box. So 0, 1. Okay, so what do you guys notice? I just put 0, 1 there. If I were to sketch my graph, we know the general shape. It's down on the left, up on the right. If I were to come over here, don't do this, but if I were to come over here and graph this, look at what happens. In order to make this growth, it would have to go through that asymptote, but don't we know we can't do that? That's how we know that what we've got is not our final answer. So step 3, 4, and 5 are to shift horizontally, reflect, and to shift vertically. And I'm just going to follow the order that I've got over here in this table. So I have no horizontal shift, no reflection, but I do have a vertical shift of up 2. So I'm going to take that point 0, 1, put your pencil at 0, 1, and we're going to go up 2. Up 1, up 2. Okay, that is now my final anchor point because I don't need to move it anymore. So my final anchor point is 0, 3. Since I don't need to move it anymore, I'm ready to sketch my graph. So I'm going to come over here. I know it's growth, so it's going to go down on the right, and it's going to go up, or down on the left, and it's going up on the right. So the red is my final graph. Okay. And it does ask me to find the y-intercept. Well, do you guys notice something? Do I really need to plug in a 0 for x, or is my final anchor point my y-intercept? Yep, your final anchor point is your y-intercept. If that happens, then you don't have to do it algebraically. But you could, and if you were to do that, you would get f of 0 equals 3 to the 0 power plus 2. 3 to the 0 power is 1. 1 plus 2 is 3. You still get the same thing. Okay? So let's move on to number 2. Number 2. 2 times 2 to the x power minus 1. Okay, so here's my a, and here's my b. Do y'all agree? 2 in the front is my a. The 2 in the parentheses is my base. So is this growth or decay? Hopefully you're saying this is growth, right? All right, so my initial anchor point is 0, comma a. Well, my a, I put my a under there, is 2. So the initial anchor point is 0, comma 2. Okay? So I'm going to keep filling in H, R, and B. Horizontal shift. Is there anything going on up there with the X? Hopefully you're screaming at me saying no. So there's nothing going on up there with the X. Then my reflection, I'm looking for a negative in the front. There's no negative in the front. Or I'm looking for a negative in front of the exponent, and there's no negative there. So that means that there is no reflection. Then I'm looking for a vertical shift. Well, that comes back here. Okay, so I have a negative 1. So that means down 1. Okay, I'm going to come over here again. I didn't do this a minute ago. I'm going to sketch what I know this shape needs to look like. I know growth is down on the left, up on the right. All right, so I'm ready now. I know from the vertical shift, my k value, I know my asymptote. So I'm going to go ahead and I'm going to write y equals negative 1. That's something you guys should always be able to get correct. That's also the first thing that you plot. So you go to the y-axis and you find negative 1, and you're going to have a horizontal dotted line. You have a horizontal dotted line at y equals negative 1. Okay, so the next thing is to plot the initial anchor point. So we're going to plot 0, 2. Okay, you guys notice that this graph has a dilation in the front. It has a dilation of 2. And if you remember from the notes that we finished just a minute ago, we said that the distance from the anchor point to the asymptote was equal to the a value. Okay, so if you look right now, I'm 3 units from the asymptote, but my a value is 2. So I know that that anchor point is going to need to move some kind of way so that it's 2 units from the asymptote. Okay, so I go over, I'm checking out my H, R, and V, and I see that I need to move down 1. So I'm going to take that 0, 2, and I'm just going to move that point down 1 unit. That's all I had to do, so that's my final anchor point, 0, 1. I can sketch my graph. It's going to go up on the right. It's going to go down on the left. Now look, do you guys notice? We said, hey, this needs to be the same. Isn't that 2 units right there? It matches the a value. Okay, y-intercept. I can do it algebraically, but if it's the y-intercept on the graph, I can go ahead and fill it in. 0, 1. So you don't have to do this one algebraically. Okay, hopefully this isn't too terrible. You've only had to do vertical shifts for these. Okay, so flip over. So now we're gonna do 2 things, okay? So number 3, 1/2 to the x plus 3 power minus 3. All right, guys, whatever's in parentheses, this is your base, okay? What is understood a value in the front here? Your a is not 1/2. Whatever the exponent is attached to is the base. It's a 1, okay? So your a is 1. If your base is 1/2, is that growth or decay? Hopefully you guys are saying decay. So we're going to circle decay. Decay is up on the left, down on the right. So I'm sketching the shape of that graph over here on the right side. Okay, so my initial anchor point is 0A. Okay, so my initial anchor point in this case is 0, 1. Okay, horizontal shift, you want to look at the exponent. Okay, do you guys see this right here? There's x plus 3. Well, remember we said, hey, we go the opposite direction of the sign. Well, the plus 3, we would think positive. We would think right 3, but remember, opposite. So we're going to go left 3 units. Okay. Reflection, is there a negative in the front? Nope. Is there a negative in front of the exponent? Nope. No reflection. Okay, then for my vertical shift, I'm looking back here in the back. That's my K value, down 3. And I'll also know that's my asymptote, so I'm going to go ahead and write y equals -3. Okay, so I have filled everything in. Okay, so now we're ready to plot the asymptote first. So I go to -3, y equals -3. And we're going dotted line at y equals -3. Okay, and I'll plot my initial anchor point, 0, 1. Okay, so now after I've done that, I go back to my table over here, and I'm going to follow this order. I have to go in the order HRV. So the first thing I'm going to do is I'm going to move left 3. Okay, so I'm going to go to 0, 1, and I'm going to move that point left 3. I'm going to go 1, 2, 3 units. Okay, so that actually put me at -3, 1. If you want to make a note, that's what that ordered pair was. That was the shift left 3. Okay, so I've done that. Now I'm not done though. I need to move down 3. So I'm going to go from -3, 1 now, down 3 units. 1, 2, 3. Well, that was the last move. So this is now my final anchor point. That's -3, -2. Okay, so now I can sketch my graph. Well, remember over here, that I just circled in yellow, we said, hey, that's the shape that we need to take, because you might get a little confused and not remember exactly how to draw it. Oh, wait, I'm sorry. We need to do something else first. This point, -3, -2, is not the y-intercept, so I should probably find that first. Can we do that algebraically? Okay, so what I'm going to do is I'm going to plug in a 0 for x. So f of 0 is 1/2, use parentheses. So parentheses, 1 divided by 2, close it. Then 0 plus 3. Well, you know what 0 plus 3 is. If you punch caret 0 plus 3, that 0 plus 3 has to go into parentheses, or it's not going to give you the correct answer in your calculator. Okay, what I would do is, you know what 0 plus 3 is, don't you? 0 plus 3 is 3. So in your calculator, you guys need to do parentheses, 1 divided by 2, close the parenthesis, caret 3 minus 3. Okay, and that's going to give you -2.9. Okay, so your y-intercept is 0, -2.9. So I'm going to go plot that. That's somewhere down here. Let me use the red so it matches. Somewhere down here. Well, hey, that shows you that this graph's getting close down there on the right side. So then I can come in and sketch the rest to the left. Okay. So if you need to figure out the y-intercept, you need to find it and then graph the rest of the graph, because you've got to have that point included on the graph of the function. All right, number 4, 0.5 times 4 to the x plus 1. Okay, so 0.5 is my a, do you agree? And my base is 4. So if my base is 4, that's growth. So I'm going to circle growth. I'm coming over to the side and I'm saying, hey, that's up on the right, down on the left. That's what growth looks like. Okay, my initial anchor point is 0A. Okay, so this time the initial anchor point is 0, comma 0.5. Okay, horizontal shift, I'm looking at my exponent. There's nothing up there, there's just an x, so there's no horizontal shift this time. Reflection, is there a negative in the front? Nope, that's a positive 0.5. Is there a negative in front of the x? Nope, so there's no reflection. Vertical shift comes back here. That's your K value. It's a +1. So that's up 1. And when I write that up 1, I'm automatically going to go down to my asymptote and I'm going to write y equals 1 because I'm not going to miss that because I know that I can do that no matter what. I know I can write that equation of the asymptote. Okay, so let's graph it. So I'm going to plot y equals 1. Horizontal line at y equals 1. So then I'm going to plot the initial anchor point. Okay, the initial anchor point is at 0.5. It's right there. Do y'all agree with me? Do y'all agree? So here's the problem. If I were to draw my growth through that point, don't do this, it crosses through the asymptote. We know that can't happen, don't we? Okay, so I need to fix that. I need to remember that I got to go back and look at my H, my R, and my V. Well, my V is telling me to take that 0, 0.5 and move it up 1. Well, if this is at 0.5, when I move it up 1 whole unit, it's actually going to move up to 1.5. Do you agree? So now my final anchor point is 0, 1.5. And now I'm ready to sketch the graph. It's up on the right, down on the left. We like problems like these because do I need to find the y-intercept algebraically? Nope, we found it in the final anchor point. So it is 0, 1.5. All right, so just remember, when I shifted, I want you guys to come back and look. When I went from 0.5 right here, when I go up a unit, since it's a half, when I add 1 to a half, it goes to 1.5. Okay, good deal. 2 more. All right, so now I'm looking at number 5, -3 times 1/3 to the x plus 1. Here's my A and my B. My base is 1/3. What is that? It's a K. That's up on the left, down on the right. Okay. All right, so my initial anchor point. Here's where we're going to get a little tricky, okay? Your initial anchor point is the positive number, okay? I know it says -3, okay, but A, we're going to say A is 3, okay, 0, A. So we're going to have 0, 3, because the negative is telling me reflection, okay? So 0, 3, I'm ignoring the negative for the anchor point. Make a note if you need to. Ignore negative. That's an N, not an H. I just messed that all up. Sorry, y'all. Let me try to rewrite that. Ignore negative. Okay? That's just for the initial anchor point. Horizontal shift. Is there anything going on with the exponent? No. But now there is a reflection. There's this negative in the front. That means x-axis reflection. Okay, I'm using this box to help me. If there's an x-axis reflection, this decay function that was up on the left, it was up on the left and down on the right, what's going to happen is it's going to flip over that line and it's going to look like this, isn't it? Right? So I need to remember this green shape is the one that I want my final shape to be. Vertical shift. What's going on in the back? Up 1. We've done a lot of up 1s, right? So I also know that's my asymptote. So y equals 1. So the difference this time for us is that there's a reflection, and we know that's not really going to mess us up too much. Okay? All we know is it's just going to change the shape of the graph. Okay? So let's do this. So y equals 1. I go to y equals 1 and I put a dotted line. And I plot the initial anchor point, 0, 3. Okay, so those are in red. Now, I know that the graph has to be flipped. So if I were to sketch the flipped graph right now, look at that. There's a problem, right? It goes through the asymptote. That can't happen. So we got to remember, hey, I got to do some stuff. Okay? First thing is the horizontal shift. There's nothing. Second is the reflection. All right, so let's do that. I'm going to reflect over the x-axis. Be careful. You're not reflecting over the dotted line. You're going to be tempted to do that because it's bold and it's in your face. I'm going to come right here and I'm going to make my x-axis real heavy and dark. All right, that is what I'm actually reflecting over. Okay, so if my anchor point is 1, 2, 3 units above the x-axis, which is the line that I just did in black, I'm going to flip it 3 units below 1, 2, 3 down here. Okay, so that flips it to 0, negative 3. Do you agree with me? All right, so don't flip over the dotted line. You're flipping over the x-axis that I made heavier. Then we're going to shift up 1. So I'm going to take this point right here, this 0, negative 3, and I move it up 1, and I'm putting it in blue. That's my final anchor point, 0, negative 2. So now I'm ready to sketch my graph. All right, we made a note of what the shape needs to look like. I'm coming back. I'm circling it in yellow over here. Remember, the reflection changes the shape. So my shape needs to be flat on the right and down on the left. Okay, so that is a reflected decay function. Okay, y-intercept, do I need to do it algebraically? Nope, because that was the final anchor point. Good deal. One more. Oh, it's got 2 stars. Wonder what that means. All right, 2 to the negative x minus 2. Okay, there's no number in the front. I'm going to put a 1 so that I don't think that my a is 2. I know my base is 2, my a is 1. My base is 2, that's growth, right? All right, growth is down on the right, up on the, I keep saying it backwards, down on the left, up on the right. Here we go. Initial anchor point is 0, comma, a. A is 1, so 0, 1. Horizontal shift, I look up here at the exponent. X minus 2, we go the opposite direction, which is going to be right 2. You do the opposite of the sign, so right 2. Then I'm going to reflection. Is there a negative in the front? No. Is there a negative in front of the x? Yeah. Negative in front of the x means a y-axis reflection. Okay, so I'm going to make a note here. I'm coming over here to the side. So if I had a graph that looks like this, if it's growth, okay, if it reflects, the y-axis runs this way, doesn't it? If it reflects over that y-axis, this red graph is going to reflect and do this. This is going to be what the final graph looks like. Do you guys see that shape? So what just happened? The red reflects over to the green. Okay. Vertical shift. None. I want to go back to this red and green right here. What do you guys notice happened? This y-axis reflection made this was growth, right? It's making the shape go from a growth to a decay. It's interesting. Okay, so vertical asymptote. There's no k, so that's a 0. We haven't had one of those, so y equals 0. We plot that point. I plot the initial anchor point, 0, 1. Okay, now I'm ready to come back down here, and I'm doing my H, my R, and my V. Okay, H comes first. I'm going to move 0, 1 to the right 2 units. 1, 2, that puts me right there. That puts me at the point 2, 1. Okay, now I need to reflect that over the y-axis. I'm going to make it darker. Here's your y-axis, isn't it? So if my red point is 2 units to the right, it needs to reflect over and be 2 units to the left. So that's -2, 1. Good thing we're almost at the end of these notes, guys. My voice is giving out. -2, 1. That's your final anchor point. So now I'm ready to sketch my graph. So I'm going to erase this just so you don't get confused. I darkened it so you could see the reflection. Okay, I'm ready to sketch. So remember, the red was before, so it was growth originally, but there's a y-axis reflection that's changing the shape. So now when I actually sketch this graph, I'm going to be up on the left and down on the right, because the y-axis reflection, and you can write this, the y-axis reflection changed the growth to decay. Okay. And I messed up. I didn't do something very important that we needed to do, and it ends up being about right. But the y-intercept, f of 0 equals 2 to the -0 minus 2 power. Okay, so in your calculator, guys, you want to do 2 caret parentheses -2. We know 0 minus 2 is -2, and that's going to give you 0.25. So your y-intercept is 0, 0.25, and that's really kind of where I drew my graph, so it's there. Okay, so this is how we're doing this stuff. All right, so the next class period, you guys are going to be working on, or now if there's time at the end of this one, you guys are going to do the homework sheet. You're going to go back and recheck that and finish the one from Monday, and then you're going to work on the 2 problems here at the bottom. Okay, and then there will be a practice sheet for you guys to work on as well. So you'll have plenty of work to practice these to be ready to show me what you can do when I come back on Thursday. Good job, guys. Y'all have a great day.